So I will clear. We don't need to be at origin anymore. We'll start a maze. We'll explore it. And then we'll re-trigger the maze by... Oh, wait, we don't actually harvest. Let's take a parameter. And if we restart, then we just use the appropriate amount of weird stuff. Else we harvest. And okay, I'm a little bit lazy here, so does this work? Nope. Oh. So now we're looking for the treasure. Oh, we can't do that because... why did that not work, actually? Oh, because we just appended here. We need to reset the layouts in init. Was outside of the bounds. List is empty. Oh, whoops. Call. Wait, we are calling the init. How can you be 0? I'm literally making sure you're not 0 here. You must be drunk. You're not drunk. Layout in its wholesome is empty. At this point, how? How? That's how. Is it? Shouldn't be, but... Okay, and what is n? N is 12. Okay, and then we go in here, we do a bunch of stuff, right? Layout is not empty. I don't want to talk about it, chat. A little bit of variable shadowing. Hey, would you look at that? And making money. Or treasure, as it were. However, there's no point to doing this right now because we are not making use of the information we have obtained from the previous explorations. However, at least we can do the thing. And we got some gold. Maybe that'll allow us some upgrades. I do want to get into cactus, but first I want to just get mazes on lockdown. Oh, let's just get these. Oh, that's just the cost of the unlock. I thought that was the cost of the operator. Yeah, let's get the automatic unlocks. Why not? Let's improve our grass growing. Our carrots. Watering trees. Pumpkins. Right. How do we then... Oh, this is... This little bit here is basically what makes this harvest stuff. So yesterday I thought we could do a star to plot a path through the maze, and we can do that. However, a star pretty much requires you to have a heap or a priority queue to get good performance. And we don't really have access to that, and I don't really feel like implementing a heap or a priority queue. We actually maybe. Oh, it's disgusting, but it might just work. God, it might just work. All right then. If you're under the ripe age of 25, then close your eyes, because this might be this might be disgusting. Well, let's send our robot on. Actually, hold on. Mr. Robot, sir? Yeah, have you just do some growing while we figure out the code here? Okay, so we have the layouts. And let's see now, we need a fringe. For the A-star algorithm. So this is the set of, well, the what should be a priority queue of nodes to explore next. I'm gonna make this into a dictionary, and you will see soon why. This is priority to node object. And then we'll have a visited. Do we? We don't actually need that. I don't think. I think we just need the lowest cost to get to this node here, and we'll have the max cost. What is the maximum cost? Do we have constants? Is there like a max float? I guess we're just gonna pick a large number. That should be large. I'm feeling a little bit uneasy. What if they're using int32? I don't want to mess around. It's unnecessary. So the cost to get to any node is the maximum possible cost. And we will, for column in layout, and then for a node in the column, we will set the node's cost. We will just initialize everything to max cost when we start over. We could maybe potentially do something smart with generation numbers to avoid this, but not worth it right now. And then we will get the root node, which is the node where we're currently at. It obviously has a cost of 0. That's our starting point. And it's added to the fringe. Now we're gonna make something dirty here. Where's my node? Where's my node at, yo? Here. Node, I'm gonna just priority. Call it node priority here. And we're going to return the hold on. What was the priority of a node? Right, we need to take the node's cost plus the heuristic, which is basically the taxi cab distance. Let's just add that to our utils, by the way, while we're here. Let's call it Manhattan dist. Now something to decide tracking what I'm doing, but possible later. Given how much more efficient trees are than bushes, how much quicker I'm bringing in wood and other resources, maybe check a border with trees and grass instead of bushes. That's an option for sure. Hold on, let me just finish my my train of thought here. And I shall get to you in a moment, sir. Or ma'am, or other. So, you weren't here yesterday when we made our thing, but we're not doing fixed patterns. We have a thing that... Can we not have this flickering thing? Basically, nej, sluta. We have a thing... Where is it? Here, that selects which crop to grow. And it does this per tile basis. So it makes sure that we always have more hay than wood, more wood than carrots, more carrots than pumpkins, etc. And then it makes this decision on what to grow for each tile, so we can have a mixed field. Like this, for example. And now it's going to just move into pumpkin mode here. But when I need trees, it's going to plant the checkerboard pattern for trees and grass just because we need trees. So it's a good suggestion, but it doesn't really work with how we do things in our code base. Okay, after the pumpkin is done, we should probably... I don't think it matters that we stop there. Okay. We'll add the root node to the French. No, wait. That's not how that... Okay, so we need to compute the priority. This is the estimated cost. And then we need a subkey, which is basically, let's do position 0 divided by 100. That divided by that. So assuming we have less than 2 digits of position, we're going to use 0, the range of digits from. So we're gonna have a number that looks like this, or this is the x coordinate and this is the y coordinate. So this is just going to be a way to avoid collisions in our dictionary while still being able to extract the minimum element from the dictionary. Your OCD is starting to play up watching my drone work, but it's efficient. It's maximum efficiency. Not sure why I did that then. So anyway, this is going to create that priority. So we will add this to the fringe. So this will allow us to have as long as the same node is not on the fringe twice, which it shouldn't be, because it's a dictionary. This will allow us to use the dictionary as a priority queue kind of thing. So, while we have something left in the fringe, then how did the min function work with dictionaries again? Don't actually know. Does it return the key? The entity? So we'll have something that looks like this. Does this print? Okay, so it just prints the key, returns the key. Okay. I spent so much time in Germany, reject efficiency, embrace chaos. I mean, we're not playing Dungeons and Dragons, so we're not doing the chaos thing. This gets the min key. And min node then is fringe for the min key. And we need to the min key. Will that do what I think it does? Geez, I don't want to have to create the dict again. God damn it. It's fine. Remove on non-list or set. Oh. Nanny? I was sure that was how remove works. Dicts. That's. Okay. Mm-hmm. Oh, pop. Sure. Okay. Okay, so that does the thing. Good. Off you go. That gets the next node of the fringe. And then we need to, for each of its neighbors, put direction in nodes corridors. And we need to make our... Is that how that's spelled? I'm making a fool out of myself. I mean, that's why you're all here. Then we get the node from the layout. You know what? Save my embarrassment. There's our next node. And the new cost to get here is the min node's cost plus 1. If the new cost is less than the next node's old cost, then the next node's cost is equal to the new cost, and we need to keep track of where we came from. For now, this will be none. This will be how we get our path later. So, we came from... we're moving east. So we came from the west. Will this make sense? Hold on.